Computer networks. That's the topic of this short video tutorial, and we're just going to be talking briefly about the types of networks and the types of connectivity that are available. A network is created whenever two or more computers are connected. They would be connected using cables or through a wireless device, and the purpose is to share information and resources. Any device attached to the network is considered a node. A printer connected to a network would be a node. A server would be considered a node. Even a laptop computer would be considered a node, even though it's connected wirelessly. Note that that it isn't necessary to connect to the internet when you're setting up a network. And as an FYI, and you'll want to remember this one, the most common type of node is a workstation, so a desktop-style computer. Different types of communications media. First, analog, and that's information is transmitted through continuous transmission signal. Let's see. A telephone, for example, takes sound vibrations and turns them into electrical vibrations before they're transmitted over phone lines. Digital is the more common these days because information is transmitted through ones and zeros. So something is either on or off. And because digital data is preserved perfectly at high speed, the millionth copy of a computer file is exactly the same as the original, which is a very nice feature. Fiber optics are something that are growing in popularity, although they're rather expensive still. And with fiber optics, information is transferred or transmitted through strands of pure glass that is as thin as a human hair. Because information is transmitted as light, and light travels, I think it's approximately 186,000 miles per second, something like that. Anyway, fiber optics are very fast. So a light pulse is pushed down very quickly, and a pulse on is a 1, off is a 0, and that light is converted into electrical impulses that a computer can use. In all topologies, one computer acts as the client, and that's requesting the information, and one computer acts as the host, and that provides the information as requested. So it's important that you see that there's a client and host relationship. The host gives, the client gets. Servers perform critical functions on behalf of other machines or clients on a network. Functions can include user authentication, data storage, running large resource-intensive applications such as databases. Most modern computers are equipped with both a NIC, so a network interface controller, and a modem. NIC cards use digital computer signals and modems use analog signals over phone lines, so depending upon what's available to you. A modem has a smaller connection, and it's starting to become less common now that local area networks and things are becoming the standard. A modem is used for connecting to the internet through a dial-up connection, that terrible sound thing, and it's been superseded by broadband connection, so that runs through a router, connects to your computer, through the network port, or through a USB connection. In this picture shown here, the NIC card is represented by the LAN connection. It's also called an Ethernet port. And the modem connection is that smaller one. It's the same size as a phone jack plug. There are three primary network types: a LAN, which is a local area network, a MAN, metropolitan area network, and a WAN, which is a wide area network, and they're pretty much categorized by size. Local area network would be a home network or a small office. A metropolitan area network might be a city or a campus, and a wide area network might be multiple campuses, multiple cities, regions, states, countries. The largest WAN in existence, WAN, is the Internet, and that's a wide area network because all of the computers on an Internet are connected. LANs connect network devices over a relatively short distance. A networked office building or a home usually contains just a single LAN. The two main types of LANs are peer-to-peer and client-server. We saw before that the client-server is one gets, one gives, and in a peer-to-peer, they can both give and both get. When several computers are interconnected but no computer occupies a privileged position, that's when the network is referred to as a peer-to-peer network. So every computer can communicate with all the other devices on the network, or all the other nodes on the network. But in general, each computer stores its own files and runs its own applications. In a MAN, a metropolitan area network, it's quite common that it connects two or more local area networks or campus area networks together. It doesn't generally extend beyond the boundaries of a metropolitan area. WANs, wide area networks, refer to networks that cover a broad area. Generally, any network whose communication crosses smaller boundaries. As I mentioned before, the Internet is the largest wide area network. Related to the LAN is the WLAN. A WLAN, a wireless local area network, uses radio waves rather than wires to communicate between nodes. Another name that you might recognize more easily is called a Wi-Fi network, and that's the same thing. Wi-Fi stands for wireless fidelity. Another name for the WLAN, which you may recognize more, is Wi-Fi. And a Wi-Fi stands for wireless fidelity. It's the same thing as WLAN. Another type of network that is growing in popularity is called cloud-based network. In this model that is shown here, an organization works with a third-party vendor to host data, applications, and other resources on the third-party servers. End users would manage their computers and applications using a web browser. For example, in cloud computing, instead of having to purchase and install amounts of storage for your computer, the company would subscribe to a virtual storage company and save files and programs on the external company's network. As storage space increases, they would purchase just a little bit more storage on this larger network. If their storage needs decreased, they could lower their cost for storage. And it's very elastic, and it can suit the needs of a changing business. Google Docs is an example of a cloud business application. Multiple people can take turns collaborating on a document, and it's saved in the virtual environment. That way all participants can access the document whenever and wherever they need it, as long as they have internet access. Dropbox, that's a program that I use, and it's an example of cloud storage. At no charge, I'm provided a small amount of storage on a virtual server. And the files that I want to save and be able to get to from other computers, if I've got Dropbox installed on whatever computer I'm going to be using, I can access my files wherever I am. It's a very cool program. Dropbox.com. I encourage you to check it out. Let's talk a little bit about network topology. Network topology is the layout pattern of nodes within a computer network. Physical topology means the physical design of a network, including the devices, location, and the cable installation. Logical topology refers to how data is transferred within the network. To determine the type of topology that's used, you'll map the data flow between nodes. The physical shape of a network does not necessarily correspond to the actual physical layout of the devices on the network. For example, in your, the computers on a home LAN may be arranged in a circle in a family room. But it would be unlikely to find a ring topology there. For the purposes of this class, we're going to be focusing on physical topology. Focus on the 5 basic topology types and take a look at each one. The simplest topology is a permanent link between 2 nodes. Let's see, think of a child's tin can telephone. The 2 nodes might be 2 workstations or maybe a computer and a printer. And next is a bus topology. So in a local area network where bus topology is used, each node is connected to a central cable. A terminator is required at the end of the bus cable to prevent the signal from bouncing back and forth. A signal from the source travels in both directions to all machines connected on the bus cable until it finds the MAC address of the intended recipient. The cable that runs between the nodes and their dedicated cables is called the backbone or trunk. In a local area network with a star topology, each node connects to a central hub with a point-to-point connection. All network traffic passes through the central hub before moving to another node. The star topology is considered the easiest topology to design and implement because of the simplicity of adding additional nodes. The primary disadvantage of the star topology is that the hub, well, it represents a single point of failure. If it doesn't work, nothing works. A ring topology is set up in a circular fashion, with data traveling around the ring in one direction, and it travels until it recognizes the computer address or MAC address that it specifically wants.